Hi students, I came back with one more video, that is Latin square design. In this you will be having a square matrix like 3 by 3, 4 by 4, 5 by 5, and it may be increasing. Here in 3 by 3, what is the main thing in Latin square design is we are having the number of treatments is equal to number of rows equals to number of columns. If we want to take example for 3 by 3, we are going to have the value of A once and only once in that row and column. A is nothing but one of the treatment here. Similarly, we can check each and every treatment over here. It should be once and only once in each row and in each column. Such layout will be known as Latin square design. We can write 3 by 3, 4 by 4 and 5 by 5. What 3 by 3 means? Number of treatments is equal to number of rows equals to number of columns. So, as we have been explaining about the Latin square design, previously I explained about the randomizer block design and completely randomized design. Likewise, here also we have some steps to find out the problem. How to find the ANOVA for three-way classification. What is meant by three-way here? We are going to have treatments, rows, columns. For this, we are going to have somewhat effect. For that sake, we are going to find out the setting of the null hypothesis H0, where H0 is nothing but H01, H02 and H03. What is meant by H01? We are going to tell about the between treatments, here between rows and between columns. Now, calculating the grand total G. What is meant by grand total G? G is equals to, we are going to have the total of the values. What is the correction factor formula? Correction factor formula is G square by capital N, where capital N is equal to M square. M square is nothing but the number of value M into M, that is 3 by 3 means 3 into 3, 9. Next 4 by 4, that is 4 into 4, 16. 5 by 5, that is of 25. We are going to get the capital N value by taking the 3 by 3 or 4 by 4 or 5 by 5. Now calculate the raw sum of squares. What is meant by raw sum of squares here? Each value is going to be squared and added in the given problem. That is summation I, summation j, summation k, xij k square. I refers to number of treatments. I refers to number of rows. J refers to number of columns. And k refers to number of treatments. So total sum of squares is equal to raw sum of squares minus correction factor. Sum of squares due to treatments is equals to, you are going to have I know Tii dot dot. Why? Because dot dot means j and k are going on changing here. Here sum of squares due to rows, sum of squares due to columns, and we are going to have the error sum of squares. What is meant by error sum of squares? Sum of squares due to error is equals to total sum of squares minus sum of squares due to treatments minus sum of squares due to rows minus sum of squares due to columns. After this, we are going to find out the ANOVA table and we are going to draw the conclusions. So here I have given one problem based on Latin square design. See, here the table below gives you an yield of rice in kilos observed in a field experiment carried out in 4 by 4. So here 4 by 4 Latin square design means how many values you will be having? 4 square. Capital N is equal to 16 you will be having. Okay. So here, and you can check that the value of A is once and only once in this row and in this column. That you have to find out. For the given question, I have found out the totals. What are the totals here? You are going to find out the row total and column total for everything. While you are going to adding all the rows totals and columns totals, you are going to get your grand total G. G is equals to 213 here. Okay. Now, to find out the treatments sum of squares due to treatments, I am going to make a table based on treatments. How many treatments we have? A, B, C and D. For this, from each row and column, we will be having the treatments. No, we are going to write that values from the given question. A is how much here? 12. Here is 7. Here is 5. And here is 7. You are going to write in a row for the treatment A. Similarly, we are going to write still up to D. Why we are finding out another table is to find out the sum of squares due to treatments. Okay, that's why we are going to find out the values of this. Now, we are going to find out the value of G. What is meant by G? Grand total, which we have already found out in the previous table. What is the formula for correction factor? G square by capital N. G square is 213. By capital N, I already told you it is of 4 by 4, which you are going to get 16. We are going to have this value to find out the correction factor. Next, it is of raw sum of squares. As I already told you, raw sum of squares is equals to sum of squares. Each and every value, whatever they have been given, you are going to be squared and added. That will be called as raw sum of squares. Now, what is the next one? Total sum of squares. What is the formula for total sum of squares? Total sum of squares is equals to raw sum of squares minus correction factor, which we have already found out here right now. Now, treatment sum of squares. How we are going to find out the treatment sum of squares? Sum of squares due to treatments. In the previous table, that means here, see, what is the value of treatment A? Total 31. So 31 square plus 61 square plus 85 square plus 36 square. All these totals you are going to be squared and added. By how many number of treatments you are having, ma? 4 minus correction factor. With that, we are going to get the sum of squares due to treatments. Now, what is the next one? Row sum of squares. I already told you the row sum of squares you are going to get from the given question only. See here this table. 49 square. This is the row, no? Column. Row is this one and column is this one. While you are going to find out the column sum of squares, you are going to use these values. And for row sum of squares, you are going to use these values. Okay. Now, the row sum of squares is equals to 49 square plus 43 square plus 58 square plus 63 square. That these values you are going to get from this. Similarly, columns you are going to get from this. Then, sum of squares due to columns. I already told you these the values are also coming from the given question only. Columns you are going to add their totals and the totals will be squared and added. And the denominator value will not be changing at all. Why? Because it is of m only. The number of values here 4 by 4, no? That's why here you are going to have 4 only. Now, sum of squares due to error. What is the formula for sum of squares due to error? Total sum of squares minus sum of squares due to treatments minus sum of squares due to rows and sum of squares due to columns. With that, you are going to get sum of squares due to error. After finding out this, I already told you this is the ANOVA table pro forma, which is having the sources of variation, degrees of freedom. S dot S means sum of squares. M dot S means mean sum of squares, and the last one is F ratio. In the F ratio, you will be having two separate columns. The first one is F calculated value and the next one is F table value. Treatments. How many treatments you are having? 4. 4 minus 1 is how much, ma? 3. Next, rows. How many rows you are going to have? 4 rows. 4 minus 1 is 3. How many columns? 4 minus 1, which is of 3. And error. Error is of m minus 1 into m minus 2. Why m minus 1 into m minus 2? This is the formula. Or else, you can find out the total degrees of freedom first. That is of capital N minus 1. Total is of 16, no? 16 minus 1 is how much? 15. This is the value of 15. From this, you are going to subtract the degrees of freedom for total treatments, rows and columns. You are going to get your error degrees of freedom. Now, whatever we have find it out, treatment sum of squares, row sum of squares, column sum of squares, error sum of squares and total sum of squares, we are going to write all the values from the previous what we have been calculated. Now mean sum of squares. What is meant by mean sum of squares? Particular sum of squares divided by its degrees of freedom. This one divided by 3, this one divided by 3 and this one divided by 3. How we are going to get the F calculated value? F calculated value is nothing but F1 you are going to get the treatments effect. So treatments divided by error degrees of freedom. Okay, that means error mean sum of squares. 155.0625 by 13.2292. That you are going to have here 11.7212. For F2, 20.0625 by 13.2292. Denominator will not change. Numerator will be changing. For F3, 14.2295 by 13.2292. Which is going to follow the table values. For F1 calculated value and F table value, we are going to have all the degrees of freedom. For the first one is 3 only, and for the second one you are going to choose the error degrees of freedom, that is 6. For all the 3 conclusions whatever we are going to draw for treatments, for rows and for columns, we are going to have the table value same, that is 3, 6 is 4.76. This we are going to get from the tables of F. Okay. Here the F calculated value, F1 calculated value is 11.7212, which is greater than 4.76. So we reject H0 1. That means there is a significant difference between the treatments you are going to write. Here F2 calculated value equals to, we got 1.5165. which is of less than the table value, where the table value is how much, ma'am? 4.76. So there is no significant difference between the rows. You are going to write. Now what is the third one? F3 calculated value, that is 1.0756, which is of less than 4.76, which is you are going to accept the H03. That means there is no significant difference between the columns. Thank you.